This video covers concentration units. Please read the OER textbook chapter section 11.5 for more details. In the previous sections, you'll learn about solution and how solution is being formed. In this section, we are going to take a look at the unit that describe the concentration of the solution. Many of you might be familiar with the concentration of units by mass already. For example, percent by mass, which is going to describe the amount in grams of solute divided by the total amount of the solution, right? Grams of solution, which is coming from the solute and solvent, right? And then multiply by 100. So this percent by mass can also be described by volume as well. So for example, if you just replace these grams right here with the volume, you can do that as well, right? So instead of grams, you can do volume as well. So that would be percent by volume. But it's the same idea. You are doing volume of the solute divided by total volume, right? So multiply by 100. The second one that you might be familiar with is parts per million, which is describe grams of solute per grams of solution, but multiplied by million. Okay, so percent is by 100, right? So part per million is going to be by million. So this unit is describe something is very small. So most of the time, this part per million is used with something that describes like a small amount of the solute. Same thing for part per billion as well. So this one, instead of multiply by million, you are going to multiply by billion. Because ppm and ppb describe something very small, so these two units are often used in some contaminant or pollutant in soil or water. And again, these three units are going to be by mass. Okay, so you can also replace this by volume as well, depending on what you want to describe. The next thing we're going to take a look at is going to be the concentration units by mole. Okay, so in this case, instead of using grams, we are going to convert that to mole. Okay, so we're going to look in terms of mole. Okay, so these are the three ones that you will need to know. Okay, so you must know this, and you are going to use this throughout the whole sequence of chemistry. Okay, so let's take a look at the first unit. Okay, so the first unit is molarity. Molarity, which is going to use uppercase M. Okay, so uppercase M molarity is going to stand for mole of solute per liter of the solution. Okay, so we are going to use this often. Okay, so in this chapter 11.5, we are going to focus on this unit first. Okay, so later on when we talk about in chapter 11.7 colligative property, you are going to learn about molality and mole fraction later. Now let's take a look at molarity uppercase M, okay, which is mole of solute over liter of the solution. Okay, so in this case, I want you to know that molarity unit is also called molar concentration. Okay, so it's the same thing. When I talk about molar, it's referred to mole solute per liter of the solution, and you are going to use most often in the chemistry sequence. Okay, so let's take a look at an example here. So for example, right, so if you have to do the conversion, right, between grams to mole, mole to liter, and things like that. So molarity is actually going to help you to do that. Okay, so because this molar concentration, right, is contained two units, right, mole and liter. So that means in this case, the concentration unit molarity will also help you to convert between mole and liter. Okay, so this is really important. Okay, so that means if you are looking at this concentration 1.7 molar, right, 1.7 molar, you are going to see that it's going to actually contain two units. Okay, so which mean that is like this 1.7 is mean that is 1.7 mole of solute, okay, per 1 liter of the solution. That's what it means. Okay, so that means in this case, whenever that you see number that come with the unit, I want you to actually express in the fractional form. The reason for that is because if you express in the fractional form, you are going to be able to cancel the unit. Okay, so it's going to allow you to go from mole to liter or liter to mole, vice versa. It depends on what you want to cancel, right? So you can set up either way. Okay, so it means that 1 liter of the solution contains 1.7 mole of solute. It means that way as well. It depends on what you want to cancel. Okay, so that means this is really important. Jot this down and highlight this, right? Whenever that you see molar unit, you need to know that it contains two units, okay, which is mole per liter. Okay, so all right, this thing right here, we are going to go to number 2 now. So we are going to look at how can we calculate for molar concentration. Okay, so in this case, again, it's molarity. So it's going to be this unit right here. Okay, so it tells us that we are going to make a solution by adding sodium nitrate, right, 36.4 grams, okay, to a flask, and then we are going to add water to it. Okay, so, and this together, the total volume is 1.50 liter. So that means in this case, we know that you are going to add that, right, to water, and then total volume would be 1.5 liter. Okay, so that's what we are end up doing in the lab, right? So in this case, what we are going to do is that we know that molarity is mole per liter. Therefore, first step would be you need to convert that 36.4 grams of solute to mole first, and then the total volume would be the volume of the solution, right? Because total means you already have solute and solvent add together, so total would be the solution. So in this case, again, first step would be convert that grams, right, to mole by using the sodium nitrate molar mass, right, and then divide by the volume, which is liter, right? So again, this volume had to be the volume of the solution. Okay, so after you do that, right, you are going to get end up with mole per liter. So this would be the answer of this number 2, right? Because the unit is going to be expressed in mole of solute per liter of the solution. Okay, so when you write the final unit, you can leave it as mole per liter like this, or you can just use the uppercase M symbol that express molarity as well. So either way is fine. Okay. All right, let's take a look at number 3. Okay, so number 3 asking you about mass of potassium bromide that we need to make 2.83 molar, right, and make up to 450 milliliter. Okay, so in this case, as we know, right, we want to eventually make this, right, but we don't know how many grams of KBr we need to actually add, right? So that's what we are going to have to calculate. We need to calculate for the mass of the potassium bromide. Okay, so how can we do that? Remember, I mentioned before that the given, right, so the volume have to be in liters. So therefore, in this case, you probably have to convert that milliliter to liter first. Okay, so another thing is the unit, as I mentioned earlier, is the M, which means that it's going to refer to mole per liter. What you will need to do is you will need to actually convert this unit into 2 unit, right, mole per liter, like into a fractional form. So that way you can use it as a conversion factor. So what you can do now is set up with 450 milliliter, right? You need to convert that to liter first. Okay, so by divide by 1,000. Okay, so after you convert this to liter, then you are going to use 2.83, right? So it's going to be 2.83 mole in 1 liter. Okay, so remember I mentioned that the molar concentration, because contain unit 2 unit, is going to help you to convert from liter to mole, right? So that's what we are using now. Okay, so the next one is convert from mole to grams by using the molar mass. So add potassium bromide to bromine together, you are going to get 119. Okay, so if you check the unit, right, so volume cancel out, liter cancel out, mole cancel out, you are going to end up with the grams of potassium bromide. And this is going to come out to be 150. So far you see the question can ask you to find out the concentration in molar, right? Or asking you to find out grams of the solute, right, to make a certain amount of the concentration with a certain volume, right? So now let's take a look at number 4, right? So pretty much this is what number 4 describes, right? We are going to make 0.692 molar of potassium chloride by adding 15 grams of potassium chloride. And in order to do that, we want to know what is the total volume of the solution, right? So that means in this case, what you are going to do is you are going to pretty much looking at what is given, right? So in this case, we know that the concentration is going to be in mole per liter. So again, what I'm going to do is convert this into a fractional form. Okay, so it's going to be 0.692 mole over liter. Okay, so after we know that, then I'm going to use this as a conversion factor. So I'm going to start with the one that contains 1 unit first. Okay, so I'm going to convert grams to mole, right, because everything is going to be related to mole. So I'm going to use the molar mass of potassium chloride. Okay, so now once I convert that to mole already, the next thing is we see that this is a conversion that allows us to convert from mole to volume. So in this case, I'm going to use that, right? So it's 0.692 mole in 1 liter of the solution. Okay, so, but the problem asking us in milliliter, so the final step would be convert from liter to milliliter. Okay, so if you cancel out this unit, you are going to get your answer in milliliter. So again, for this chapter, it's pretty much going to be similar to 121 when we talk about unit conversion, right? It's the same thing here. You need to find out the conversion factor, and the conversion factor we are going to talk about here is going to be the unit of molar concentration. Okay, so and it's going to be the conversion between grams to mole, mole to grams, or liter to milliliter is going to be one of those.